Sodium-ion battery. 1. Industrialization process. Most listed companies are expected to produce in bulk this year, but the industry may actually produce in small quantities. Industry promotion caliber. Mass production in 2023. Industry reality. Trial installation in 2023 and GWH level shipment in 2024. At present, the actual design plan is not yet determined, the positive electrode is not yet determined, the negative electrode is hard carbon, the solute is nap6, and the auxiliary materials and production parameters are not yet determined. The current theoretical price of sodium batteries is approximately 19 to 123 yuan per WH, which has a low cost effectiveness. With the release of production capacity in various links within 23 years, it is expected that the cost of sodium batteries will decrease to 0.85/0.62 yuan/WH by the end of 23 and 25 years, respectively. 2. Ultimate state. Sodium-ion batteries have a cost advantage of 30% to 40% compared to lithium-ion batteries. 1. In terms of raw materials, sodium resources are abundant and widely distributed. In recent years, due to the increasing demand for lithium-ion batteries and insufficient supply of lithium resources, the price of lithium carbonate has increased from approximately 40,000 yuan per ton in mid-2020 to approximately 590,000 yuan per ton in November 2022. However, sodium element is abundant in the Earth's crust, with lower costs and little impact on price from supply and demand. Sodium carbonate is always at a level of less than 3,000 yuan per ton. 2. Aluminum foil can be used as the collector material for the positive and negative electrodes of sodium-ion batteries, further expanding the low-cost advantage of sodium-ion batteries. Due to the easy alloying reaction between aluminum collector and lithium at low potential, expensive copper foil can only be used as the collector at the negative electrode of lithium-ion batteries. And both the positive and negative current collectors of sodium-ion batteries can use inexpensive aluminum foil, which makes the cost advantage of sodium-ion batteries even more obvious. 3. How does sodium-ion battery compare to other competitive technology paths? Each with advantages and disadvantages plus coexistence relationship. 3 yuan, high-end cars, lithium iron phosphate, mid-range plus energy storage, sodium-ion, low-range plus hybrid plus energy storage, and lead-acid batteries, which will be phased out, have their own advantages and disadvantages in terms of energy density, safety, high and low temperature performance, charging and discharging rate, and will coexist in the future. In terms of energy density, sodium-ion batteries are generally stronger than lead-acid batteries, and overlap with lithium iron phosphate battery. At present, the cell energy density of sodium-ion batteries is about 70-200 Wh/kg, which is much higher than that of lead-acid batteries, 50-70 Wh/kg. At present, the energy density of sodium-ion battery is inferior to 200-350 Wh/kg of ternary lithium battery, but it overlaps with 150-210 Wh/kg of lithium iron phosphate battery. Note, in terms of inventory, lead-acid batteries account for 75% of global rechargeable batteries. In terms of increment, China's production of lead-acid batteries in 2020 was 228 GWH. Sodium-ion batteries have better high and low temperature performance. Compared to lithium-ion batteries operating in the temperature range of -20°C to 60°C, sodium-ion batteries can operate normally in the temperature range of -40°C to 80°C, with a capacity retention rate of nearly 90% in the -20°C environment, and better high and low temperature performance. Sodium-ion batteries have higher safety. Thanks to higher internal resistance, sodium-ion batteries have less instantaneous heat generation under short-circuit conditions, and the temperature of thermal runaway is higher than that of lithium-ion batteries, providing higher safety. The safety performance of sodium-ion batteries is also satisfactory when tested for overcharging, discharging, puncture, and squeezing. Good rate performance and advantages in fast charging. Sodium-ion batteries have better rate performance and can adapt to responsive energy storage and large-scale power supply, which makes them better suited for large-scale energy storage applications. Foreign market size, CAGR equals 141.3%, 2023 2027 1. Two-wheeled vehicles. It is expected that sodium-ion batteries will be the first to quickly replace in the field of two-wheeled vehicles due to their higher cost-effectiveness compared to lead-acid and lithium batteries. 2. Energy storage field. With the advantages of safety and low temperature resistance, it is first applied in user-side energy storage, communication base stations, and data centers with low requirements for energy density and cycle life. 3. In the field of passenger cars, the use of sodium-lithium hybrid technology is expected to cover 65% of the pure electric passenger car market. It is expected that the domestic demand for sodium batteries will reach 32.9 GWH in 25 years, with a corresponding market space of approximately 20.37 billion yuan. It is expected that the domestic demand will reach 137.3 GWH in 27 years, with a corresponding market space of approximately 82.4 billion yuan. 5. Current progress and potential difficulties. 1. Electrolyte. It is changed to sodium hexafluorophosphate and produced differently from lithium hexafluorophosphate. These mainstream electrolyte companies are currently unable to mass produce. 2. Industrial issues. Too many technological paths to mass produce. The industry chain of sodium-ion battery suppliers and material manufacturers is not perfect, and the materials required for positive electrodes, negative electrodes, and electrolytes are also different, resulting in higher prices. 3. Cost parity issue. The current material cost of sodium batteries is about 0.427 yuan per Wh, while the material cost of lithium iron phosphate batteries is about 0.627 yuan per Wh. When the price of lithium carbonate decreases to 200,000 yuan per ton, the material cost of lithium iron phosphate batteries is equivalent to that of sodium batteries. 6. Investment strategy needs to be noted for those with high elasticity in sales volume. Small batch shipments are expected in 2023 and mass production is expected in 2024. It is recommended to pay attention to 1. Sodium battery. 2. Positive electrode materials. There are mainly 3 technical paths. 1. Oxide type, the closest system to large-scale production. 2. Polyanion type. 3. Prussian blue type. 3. Negative electrode materials, amorphous carbon. Hard carbon may be the mainstream of carbon-based negative electrode materials, has a high degree of technological maturity, showing excellent electrochemical performance in the fastest industrialization process. 4. Electrolyte. Sodium hexafluorophosphate, not yet mass-produced. 5. Aluminum foil. Using aluminum instead of copper, both positive and negative electrodes use aluminum foil.